Hello everyone, I'm Seung Lee from Yonsei University. Today, I want to introduce our paper, Railroad is not a train, Saliency as Pseudo-pixel Supervision for Weakly Supervised Semantic Segmentation. Semantic segmentation predicts a class of each pixel in an image and requires pixel-level annotations. Meanwhile, weakly supervised semantic segmentation predicts the same pixel-level class but only using weak supervisions. Here, we focus on adopting image-level labels. Because of the supervision gap between the pixel-level annotations and image-level labels, weakly supervised semantic segmentation faces the following key challenges. First, sparse object coverage. That means the localization map only captures a small fraction of target objects. Second, boundary mismatch. It suffers from the boundary mismatch of the object. Third, co-occurrence problem. It hardly separates co-occurring pixels from target objects. For example, because the train frequently appears with the railroad, WSSS algorithm hardly distinguishes the train from the railroad. In this paper, our goal is to overcome these challenges of weakly supervised semantic segmentation by utilizing both the localization map and the salience map. Here, the localization map can be computed from the classifier trained with the image-level label by applying CAM. The salience map is obtained from the off-the-shelf salience detection model. Our key idea is the following. Because the salience map and the localization map have a complementary relationship, we make use of both information. The localization map can distinguish different objects, but does not separate their boundaries effectively. Contrarily, the salience map provides boundary information, but it does not reveal object identity. We argued that our method using two complementary information can resolve the performance bottleneck of weakly supervised semantic segmentation. To this end, we propose a novel framework exploiting the salience map for weakly supervised semantic segmentation, called Explicit Pseudo-pixel Supervision. Specifically, we focus on improving the quality of pseudo-masks obtained from an image classifier. For that, we first make class-wise localization maps compared with the class-agnostic salience map by merging localization maps into an estimated salience map. Then, our method utilizes the salience map as pseudo-pixel supervision for model training and exploit it as the cues for boundaries and co-occurring pixels. We also use the multi-label classification loss to predict image-level labels. We train the classifier to jointly optimize both the salience loss and multi-label classification loss, which can synergize the localization map and the salience map with the complementary information. From the localization map, we generate pseudo-masks for training a segmentation network following the convention. These figures show the quality of pseudo-masks from baseline CAM. Our method can cover the full extent of objects, capture the precise boundaries, and mitigate the co-occurrence problem. The quality of pseudo-masks from our EPS is better than that of CAM. Then, we train a segmentation network with our generated pseudo-masks. Our method shows a clear improvement over existing method on Pascal VOC 2012. Finally, we achieve a new state-of-the-art performance on Pascal VOC 2012 with a large margin. We further evaluate our method in MS COCO 2014 dataset and again achieve a new state-of-the-art performance. Please see our paper to find more results to justify that EPS resolves the three challenges of WSSS. Finally, we propose a novel weakly supervised semantic segmentation framework, namely explicit pseudo-pixel supervision. Our EPS can capture precise object boundaries and discard co-occurring pixels, remarkably improving the quality of pseudo-masks. We demonstrate the effectiveness of our EPS via extensive comparisons and pilot studies. Finally, we achieved the state-of-the-art performances on both Pascal VOC 2012 NMS Coco 2014. More detailed results are described in the paper. Thank you for listening.